Welcome to the course on object-oriented programming using C++. Myself, Abhinay Gulravadhamankar. We have discussing function templates part 2. Moving ahead. In this video, the following points to be covered. How to overload functions templates. How to force function templates to be called. How do function templates compare against macros? What is the difference between these two? Some prerequisites for this session is how to overload the function must be known. How to type conversion is to be used, and how to do type conversion to user defined types. How to convert this also must be known. Next, how to use the macros. What is the concept of macros? Also knows. We are expecting that this should be ready while discussing the next section of function templates overloading. In previous section, just we have seen that only function templates. Now in this section, we are going to see how to overload the templates function. Let's review the section. The templates keyword. The template keyword specify the function as a function template. Writing class T over here after keyword template specifies that function takes a generic type argument T. We can use keyword type name instead of keyword class. Okay, for example, look out the statement template angle bracket opening type name T blanket complete void return type swap name of the function and arguments and the body of the function for swapping logic. So instead of class T in container or placeholder, यहाँ से यहाँ तक placeholder डालना है, right? Placeholder. So type name is a keyword of the type T instead of class T. If you are going to be confused with the class template class, this keyword class and class that you are writing for creating objects, these are the different. These are the different. This is the different. Then you can use alternatives, that is type name. Okay. Moving ahead. In continuation with the review, a template function is used to construct a family of functions working in the same fashion as it is used. Same code but different types. Okay, they are also called parameterized or generic functions. They are also called parameterized or generic function. What the first statement says, the template function is used to construct the family of a function working in the same fashion. जो normal function use करता है वही, as it is uses the same code, एक ही code use करता है, same code but for different data types. हमने previous video में देखा है, integer, float, character swapped, right? They are called parameterized function, or we can say generic function. Each template is a skeleton for set of similar functions working on different data types. Skeleton function, right? The code contains one or more unspecified data types. Code contains one or more specific unspecified type data types. Okay, so some kind of template can be right like this: template type name T1, type name T2, and so on and so on. Container. So this is something integer get replaced. This is the float get replaced at runtime. Okay. In this way, you can also write the function templates in there. This template becomes a real function when it invoked. This becomes a real function when it invoked, when it is invoked or instantiated with a specified data type. Instantiate, okay, or instantiate. This is very important. Invoked or instantiate. Instancing with the specific data types. That type will be taken for invoking. We can replace many overloaded function with a single template function. What it say? We can replace many overloaded function with a single template function. For example, हमने my swap, my floating integer character पे हमने देखा था, तो that will be very first slide of first video. That can be replaced with the same function. Code saving is the main object of the templates. Code saving. Okay, write once and use on multiple data types. Write once, use multiple data types on multiple data. This is the functionality. This is the usefulness. A template function may be preceded by any of normal modifiers. For example, it can be inline, it can be extern, it can be static. Inline function, extern function, static function. These are the concept of C++. Hope you have already been covered in your previous section of subsequent series of C++. Right? So this can be written or prefixed with these keywords. Now, let's consider the scenario. Let's consider one scene when function template needs helps. The slide itself is a very interesting one. When function template needs helps, when it cannot be invoked. So for example, let's say the specific case here. We have min one function, take an argument A, argument B of type T here, and it is returning type T reference, all our references. This will be work fine. This will be work fine for integer float double character. What happens if we pass the two string functions? Two strings, sorry. What happens if we pass the two strings? Character is different and strings are different. Okay, strings are completely different. String strings. Character means only takes one character, and it will be converted by ASCII value, ASSI ASCII value, right? And this will not be converted to ASCII value. It will pointer at a set starting address and then string /0, right? That is the strings and pointers. Okay, what will happen if we pass the two strings to this function, right? So which string is less and which string is greater will not be changed. It will simply compare numerical value of pointers. x and y. If we pass this one to this function, so it will not checking content of that pointer. I will utilize this word content of that pointer is a string values. Okay, and what is x and y contain? X and y contain starting address of string 1 and string 2, right? Starting address means this is the address, and address are numerical. So it will not perform lexicographic comparison. Lexicographic comparison means something string 1. This is the characters of set of characters, and character by character lexicographics comparison will not be done. Instead, it will be checking pointers value. So this function will not be utilized for string purpose. Understood? Now, this is the function template that we have written needs a help. Needs a help on such type of function call, which will take two strings. Which will take two strings. Got it? Two strings are there. When this function will not be useful for this. At that time, function templates needs a help. Okay, so you have to write different functions like this. So overloaded function templates is a solution. The overloaded function templates that you know, overloaded means the same name with a different type, right? एक तो हमने templates देखा, और templates itself is a generalized thing, but उसको भी overloaded करना मतलब same name with different types, right? Different types. This is the different types. You got it? This is the template function, and this is the specific function of min1, same name, min1, sorry, min1 and min1, the same name. Same name, what is called, that's why it is called overloading, the same name with different. So we have min1 template function, and this template function get overloaded with different function of different type. Different function means the same name but different type. Okay, so overloaded template functions. Observe that the character. Okay, we will take character pointers here. We will require string comparison function, and based on that string comparison function, which will be the less that will be written as it is. Okay, now moving ahead. Template function overloading. Let's say the few points with this. We can overload a function template with a function of the same name we have seen in the previous slide. And at the time of calling function, compiler decide best suited function definition for the call. It's compiler decision. Okay, so best suit, इसके बारे में हम देखने वाले हैं, इसका एक डेमो भी देखेंगे हम. Best suit. So compiler give the function called the best suited function definition for the call. If there is an exact match, in data types, then instead of function templates, ordinary function is called. Clear? If there is an exact match, 100% that match will be executed. Function template will be omitted. Exact match in the data type, then instead of function templates, ordinary function is called. Isn't it? Now listen the last line. We can force, even if we can force ओके, बेस्ट मैच अगर रहता भी है तभी भी हम कंपाइलर को फोर्स कर सकते हैं. We can force the compiler to use template version or template function by appending this symbol, template symbol, to the function call. ये दो स्टेटमेंट समझ में आए? क्लियर? ये दो स्टेटमेंट बहुत इंपॉर्टेंट है. If there is an exact match, अगर exact match है, डेटा टाइप्स exactly मैच कर रहे हैं, ओके, फंक्शंस नेम भी सेम मैच कर रहे हैं और वहां पे ऑलरेडी एक टेम्पलेट फंक्शन ले रखा है, तो ये एग्जैक्ट मैच हो जाएगा, वो बॉडी एग्जीक्यूट करेगा. ऑर्डिनरी, ओके, एग्जैक्ट मैच मींस ऑर्डिनरी फंक्शन, टेम्पलेट फंक्शन विल बी ओमिटेड. ऐसा कंपाइलर करता है. अगर कंपाइलर को फोर्सफुली बोलना है कि आपने टेम्पलेट फंक्शन ही यूटिलाइज करना है, अगर वहां पे एग्जैक्ट मैच भी रहे, मुझे फोर्स करना है आपको कि आपने टेम्पलेट वर्जन ही यूटिलाइज करना है, एग्जीक्यूट करना है, देन वी कैन डू दिस सच काइंड ऑफ अरेंजमेंट. Force the compiler to use template function by appending template symbol to the function call. इसका डेमो हम देखेंगे, देखने वाले हैं. ओके, अपकमिंग स्लाइड्स में. Look at this illustration. Look at this. This is the template version. Okay. Look at this is a template version. We have template class. This is generalized. Okay. And this is the very specific type. Double type. Double type. Okay. Right. And suppose there is this. Suppose this is the exact match. This will definitely call this one. Okay. But what happened to this call? We have integer type, and integer matches will not be match over here, will not be match over here. So definitely this will call this function. Observe now the third case. The third case. Okay, here we have double type. We have double type, and definitely as per the previous example, this should call this one. This should call. But here we have force. Okay, इसको देखो, ये symbol को, we have forcing this to utilize this function. Isn't it interesting? Okay, this is forcing to utilize this version. Actually ये बेस्ट सुटेड है. यहाँ पे कुछ कंटेंट है तो ये यूटिलाइज करेगा ये वाला फंक्शन कॉल. बट यहाँ पे हमने फोर्स कर दिया इसको कि इसने यही फंक्शन एग्जीक्यूट करना है. ओके, चलो इसका डेमो देखते हैं. राइट, इसका डेमो देखते हैं. गॉट इट नाउ? सो लेट्स सी डेमो ऑफ दिस. ऑब्जर्व नाउ हियर. ओके, कोड देख लो आप. ओके, यहां से यहां तक देखो, ये हमारा टेम्पलेट का कोर्स है और मैंने यहाँ पे ऑलरेडी लिखा है सी आउट. सी आउट इट टेम्पलेट फंक्शन एग्जीक्यूटेड, और ये है स्पेसिफिक फंक्शन. हमने यहाँ पे लिखा स्पेसिफिक फंक्शन एग्जीक्यूटेड. कोड आर सिंपल, राइट? देन ऑब्जर्व दिस कॉल. ऑब्जर्व दिस कॉल 6 and 8. डेफिनेटली टेम्पलेट फंक्शन विल बी एग्जीक्यूटेड और हमें हमें आंसर मिलेगा टेम्पलेट फंक्शन एग्जीक्यूटेड. ऑब्जर्व दिस कॉल. This call will use to definitely specific version. Right? Now observe this forcing. Observe this forcing here, and suppose this should go for specific, but this will call template version. Okay, and definitely template function executed will be your answer. Okay, And this is by force, forcing compiler. Okay, clear? Let's execute this. Let's execute this according to that. Okay, let's execute this. Zero error, zero warnings. Listen this now. Isn't it very interesting? Right? What we say that in the first call, what will be the call? Let me show that call. Yes, this is the here itself it is call, right? Okay, fine. हमारे पास यही पे है तो हाँ यहाँ पे कर दो. Now this is the call, right? So this is the call 6 and 8. 6 is a minimum. The template function get executed. What happened to second call? Specific function get executed and 2.3 is the minimum. Correct. Now what happened here? Though there are the specific call, we are forcing the compiler to take the template version and the less than 7.3 is the answer. Template function get executed. Isn't it? This is the things need to be learned out. Hope you understood this by forcing. Let's clear my slide. Moving ahead. Okay, got it now. How we have seen that how the functions are forcing to, though there are specific functions are available, though we can force compiler. Moving ahead, our discussion with the function template versus macros. Okay, macros, right? So template functions and macros works in a different manner, completely different manner. Okay, function templates and macros are different. Macros are taken care by preprocessor by text substituting code. That is called text processing. I repeat, macros are taken care by preprocessor, okay, by text substituting code. Debugging macros is very tough, right? उसमें अगर कुछ एरर होता है तो हम नहीं डिफाइन कर पाते वहां पे. Macros is defined like this way. Define max. This is the text max a and b taken parameter, and this is the conditional one line function for less than operator, right? If a conditional or less than, right? The above macros may allow comparison of an integer data types or pointer data types. There is no way to ensure A and B are of the same type. This is very important type. Very, very important, this line. There is no way to ensure A and B, means here A and B are of the same type. हम ensure ही नहीं कर पाते. We cannot do this type. जैसे हमने A less than 0 केस देखा था और A हमारा ऑब्जेक्ट हो गया था और ये 0 हो गया था, राइट? 0. तो ऐसी केस में हमें 0 को कन्वर्ट करना पड़ता है ऑब्जेक्ट टाइप में, राइट? यूजिंग primitive to class type conversion. Then only a object less than 0 will be taken care by using operator overloading. ये कर सकते हैं, right? So that's why it is the a float है and b integer है, तो ये हम verify नहीं कर पाते macros में. That is a problem with the macro. Okay, there is a problem with the macro. Next. Macro do not perform type checking. That's why it is called not performing a type checking. In previous case में a less than b, so type is not checking. But function template performs strong type checking. Strong type checking, without which it cannot be performing. Best suited match will be done. But we can forcing to use specific to generalize template by using that forcing parameter, right? I hope you are recalling the concept. Function template gives same kind of benefit, but the strong type checking. ओके अगर आप देखते कि माइक्रोस भी वही काम कर रहा है, फंक्शन टेबल भी वही काम कर रहा है, बट इसमें एक माइन्यूट चेंज है कि ये वाला कि टाइप चेकिंग नहीं करता माइक्रो। यहाँ पे अगर 2 पॉइंट्स फ्लोटिंग है, यहाँ पे इंटीजर है, तो ये नहीं चेक करेगा, कंपाइलर विल नॉट रेज एनी इशू। बट हियर कंपाइलर विल हैव very strong type checking. All parameters are of the same type. Strong type checking is a very essential features of any object-oriented languages, and that is good features of any language, C object-oriented programming. So that's why it says that strong type checking must be there. Okay, so that's why function templates are very useful. Okay, now take a two problem statement from my side, and as an assignment to you, and you submit it at your respective class teachers, subject teachers, and upload as per their requirements. Okay. The first example as a problem practice, write a C++ program to perform matrix addition or multiplication on integer type and floating type data types. Okay, on 3 by 3 matrix. So what you have to do, you have to have a 3 by 3 matrix, that is X matrix, 3 by 3 matrix into Y matrix. Okay, Y matrix आप करते हैं 3 by 3 matrix. Okay, अभी M by N और ये भी आप करेंगे P by Q, तो P and N must be match. ये जो अरिथमेटिक्स है वो देख लो आप. ओके, एंड देन बस द सेम प्रोग्राम एडिशन फंक्शन बनाना है आपको, मल्टीप्लिकेशन फंक्शन बनाना लिखना है, जनरलाइज फंक्शन, जेनेरिक फंक्शन, multiplication, addition, and generic function आपको बनाना है on integer type data types and floating type data type. The same code can be used for floating type. Okay. The next problem statement is of second one. Write a C++ program to perform a stack push operation. Okay, you know what is meant by stack. You know what is meant by push. Okay, push function. So push and pop function and operation on integer type and floating type. Integer push, float push, character push. The same way, integer pop, float pop, character pop. Same function with different data types. Okay, go ahead and do the submissions based on this. Okay, thank you. Thanks very much.